Welcome to qnawire.
So we're going to take the origin of coordinates at the point where the ball leaves the bat, and we're going to take positive y to be upward. So first, positive y is upwards. We can then say that here, the velocity in the x direction initial would be equal to the initial velocity times cosine of the initial angle rather. So Vy initial would be equal to V initial times sine of the original angle. We can then say that here, you're first going to write down the equation for the horizontal displacement when the ball hits the ground and the corresponding equation for the vertical displacement. We know that the time t is the same for both components, so this will give us two equations with two unknowns, the initial velocity and t. And so we can say that here, delta y would be equal to the initial y times t plus 1/2 a sub y t squared. This is going to give us negative 0.9 meters. This would equal the initial sine of 45 degrees, and then this would be plus 1/2 multiplied by negative 9.80 meters per second squared times t squared. In the x component, essentially we have delta x equaling, again, we can say v initial in the x direction plus 1/2 a sub x times t squared. Here, we don't have any acceleration in the x position, so we can eliminate this. This would be times t, but we can eliminate this term, and this would be 0. And so time would be equal to delta x over the x initial, and this would be equal to 188 meters divided by the initial cosine of 45 degrees. And so we're going to put the expression for t from the x component into the y component. And so essentially we're just substituting this equation into this equation right here. And we can say that this would give us negative 0.9 meters. This is equaling the initial sine of 45 degrees multiplied by 188 meters divided by the initial cosine of 45 degrees. This would be minus 4.90 meters per second squared multiplied by 188 meters divided by the initial cosine of 45 degrees quantity squared. And so we can simply use our TI-84, 85, or 89 in order to solve for V initial, and we can just drop the units and then solve for V initial using the solve function. And so your V initial should be equal to 42.8 meters per second. Now, this would be your initial. This would be essentially your initial velocity or your initial speed. This would be your answer for part A. Now, for part B, however, we can say that we're going to use the horizontal motion to find the time it takes the ball to the fence. So we can say that here, delta x is now not 188 meters, but 116 meters. And we can then say that the initial x doesn't really matter, the subscripts. This would be the initial times cosine of 45 degrees. And so this would be 42.8 multiplied by cosine of 45 degrees. This is giving us 30.3, of course, the units meters per second. And we're trying to find t. So t Again, there isn't any acceleration in the x direction, so we can simply use the exact same relationship that we saw here. So t would be 116 meters divided by 30.3 meters per second, and this is equaling 3.83 seconds. And now we have to find the position at that. So we can then say that for part B, we can say delta y is equaling, again, the 45 degrees and cosine of degrees are equal to each other. So the initial velocity in the x direction would be equal to the initial velocity in the y direction. So this would be the initial y times t plus 1/2 a sub yt squared. However, this is just equaling 30.3 meters per second multiplied by that time of 3.83 seconds plus 1/2 times negative 4.90 meters per second squared multiplied by 3.83 seconds quantity squared. And so essentially delta y is going to be equal to, given that the fence was 3 meters high, delta y is going to be 44.1 meters. It was 3 meters high, so the height of the ball above it was hit 0.9 meters. So the ball above the ground, so we can say height above ground. This would be 44.1 meters plus 0.9 meters. This is equaling 45.0 meters. And now we can say that here, this was 3 meters high. So we can say that height above fence, this is going to be 45.0 meters minus 3.0 meters. This is giving us 42.0 meters, again, above fence. So this would be our final answer for part B. That is the end of the solution. Thank you for